Hello and welcome. I'm Morten Middelfart. Today I'll be showcasing two very different approaches to training a large language model. The RCL classification algorithm and the traditional transformer neural network, also known as TNN. The test will showcase how these two systems differ in speed, power, efficiency, and overall effectiveness. Let's dive right in. To begin, let's talk about data preparation. This is a critical step for any model training, and the processes of RCL and TNN are fairly similar. Both require structured and high-quality datasets and involve pre-processing steps like tokenization, cleaning, and formatting. The goal here is to ensure both models start on an equal footing using the same data sets for fair comparison. The only thing that is maybe a little bit easier to understand is that for RCL we teach the model by example as opposed to simply using code. Next, I'll describe the code used to initiate the training process. On the left, you see the RCL code. It's concise and it's just one line of code that specify the dataset and its training parameters. On the right, you'll have the code for the transformer neural network. You'll notice that as we scroll through, there's exactly 316 lines of code that are non-comments in order to initiate this process that we do with one line in RCL. As you can see, it's much more complex. Initializing a TNN requires more configurational steps, including specifying layer structures, attention mechanisms, and optimizer settings. Both models are now ready to train, so let's start them simultaneously. While the training process runs, let's talk a little bit about the hardware configuration for these two systems. The RCL algorithm runs on a Xeon Silver processor, whereas the TNN, the Transformer Neural Network, runs on a A100 GPU in the Google Colab system. It's important to notice, of course, that both systems are running on the exact same dataset for obviously a fair comparison. The RCL model has now finished impressively fast, as expected maybe. Now we'll pause the video and wait for the Transformer Neural Network to finish. Stay tuned, please. TNN, the Transformer Neural Network, has now finished and the results are in. We notice that the RCL system completed training in a fraction of the time. To be precise, 2 orders of magnitude. In addition to speed, there's a significant difference in power consumption. The RCL system consumed 99% less power than the Transformer Neural Network. This is obviously a substantial cost savings when deploying large language models. Now let's compare accuracy. Both models show similar levels of accuracy, with RCL showing a slight edge over the Transformer Neural Network. It's also important to notice that as the dataset becomes more complicated, then the accuracy gain by using RCL appears to be higher. In summary, today's demonstration showed several key advantages for the RCL technology over the Transformer Neural Network. It demonstrated faster training speeds, it showed extremely bigger power savings, and it also showed improved accuracy. For those wondering about the final steps required to fine-tune a large language model for deployment, such as say ChatGPT, These proprietary steps typically account for less than 10% of the total compute. The bulk of the workload, the pre-training, as we demonstrated here, is what takes up the remaining 90%. Thank you for watching. If you'd like to know more about RCL and its groundbreaking potential, stay tuned for future updates. Until next time.